So in our previous session we have seen some IP addressing where we have seen some three classes. In those three classes, A class the range is 0 to 127, B class 128 to 191, C class 192 to 223, and we use only these three classes in our LAN and WAN purpose. So we don't use class D. Class D is reserved for multicasting, class E for R&D. And then we have seen the different ranges. Three classes A, B, C, D, and E, and also we have seen some ranges. A class network supports around 256 addresses. If you start from 192, 168, an example 10.0, if you go on right, maximum I can write up to 255. So each network in a C class supports 256 addresses. Like I have already a table which gives some detailed idea. So each network supports 256. Minus 2 we need to do because network ID in the broadcast study will be discussing that. And like that you got, if you write multiple combinations, you get more than something around 2 million networks, 2097152 networks. Similar way, a B class network supports 65,536 addresses in one network. Like that, you get more than 16,000 networks. And similar way, A class network supports 16 million addresses around, and like that you get around 16 million hosts per network. Similar way, like that you get 126 networks here. So if you just try to observe here, each portion, if you see C class is having only one host portion, and each host portion is having 8 bits. So 2 to the power of 8, 256 is a range of addresses. And B class, if you see here, we got more number of host portions. So we got 2 host portions, and each portion is 8 bits, so it's total 16 bits. 2 to the power of 16, it goes 65,000 addresses. And similar way, A class supports 3 host portions, so each portion 8 bits. We can say 2 to the power of 24, around 16 million addresses. So the less number of host bits, the size of the network also will be smaller. The more number of host bits, the size of the network also will be much bigger in general. Okay, so to have a variation in the different sizes, to meet the different network requirements, we have a different classifications A, B, C. So based on that, they also classified host portions and network portions. So we have a variable network and host portions in each and every class. Let us try to add some more in detail. Like just now I discussed that a C class network supports 256 addresses. In that 256 addresses, if I take an example of this one, like if I take an example of C class here, it supports, this is one example here, you can see in this example the first address we cannot use. So first address represents broadcast ID, and we cannot use that first address. So in this network, so here I got a C class network, and similar way I got a B class network. If I just move on, I got a B class network, class B network. This is my B class network, and you can see there is one more class network, C class network. This is my A class network. Okay, so if I just consider out of these 256 addresses, we discussed that if we start with any C class address, the first 3 portions remains the same, which means 192, 168.1, whatever the 3 numbers you write, it will remain the same. And we write from 0, we start from 0. From 0 we just go with 1, 2, 3, like that. I can go maximum up to 255. So in this, the first address represents your network ID, and the last address represents broadcast ID. Similar way, every network will have a network address, and every network will have a broadcast address. The first IP address network ID, last address broadcast ID. So whatever the class you take, every network, A class, B class, C class network, will have something called network ID and the broadcast ID, and these two addresses we cannot use, means they are reserved. So the first address is a network ID. So I got some points here. Network ID, it is the first IP address of the range. It represents the complete network. So generally, if I have a network, let's say in my company I got a router connecting to my LAN, and it is connecting to some other branch office somewhere in different location. And in general, when we come to our routing configurations, these two LANs should know each other, which means they should know about each other so that they can communicate. So in order to communicate, if I'm using, let's say I'm using 192.168.1 network here. So I'm not in 1.1 on like that. We got some 100 computers here. So every device is having a separate IP. Like one device is 192.168.1.1, 1.2, 1.3, like that. So I'm not going to represent all these addresses. So all these addresses are grouped together and refer with the first IP address of the range. So the first IP address of the range is actually representing the complete network. If anyone asks you what is the network you're using in your LAN, means I'll simply say I'm using 192.168.1 network. So network ID always zeros. This is the host portion. Host portion will be always zeros. So in C class, by default there are 3 network portions and 1 host portion. If you see 0 in the host portion, then you have to understand it is the network ID. Similar way, if you take B class, you got 2 host portions, 2 zeros represent network ID, 3 host portions, 3 zeros will be the network ID. So many people have a wrong conception that they generally, whenever they see, let's say if I take an example 172.16.1.0, so this is not network ID, it is your valid IP address. So why? Because network ID will have all zeros in the host portion. So in our example, this is your B class address, and in B class by default there are 2 network portions and there are 2 host portions. And whenever you see 0 in the host portion, then only we call as network ID. So there are 2 host portions here, so which means there should be 2 zeros. If it is 0.0, then only it becomes network ID. So always we cannot say everywhere, every time when you see 0 in the last, it will not be a network ID, unless if all the host portions, like in case of C class, 1 host portion, if you see 10, that is network ID. Similar way, if you take B class, 2 host portions, 2 zeros, network ID. C class, 3 host portion, 3 zeros, network ID. So by default, the first IP address of the range always starts with zeros. So this address is actually representing the complete network, and you cannot assign this address to any device in the network. So even if you want, you can just try it out. Let me just get into my local area connection properties. Like in the previous classes, we have seen that we cannot use class D, class C addresses. Similar way, even you cannot assign the network ID. Like if I just try to give 192.168.1.0, it's a C class network, so 3 network portions and 1 host portion, which means subnet mask we'll discuss next. I'm coming to that subnet mask. Just follow the default subnet mask as of now, and if I click OK, the device will not accept your address because it says the combination of IP address and subnet mask is invalid. So all the bits in the host portion of the IP address are set to 0, which means it is clearly saying that your host portion, whatever the host portion, is simply zeros, and host portion zeros represents network ID, and that address is reserved for representing the complete network, and you cannot assign that address to any device in the network. Not only computers, you cannot even assign to router, you cannot assign this address to firewall. Any networking device will not accept this address. Why? Because this address is actually reserved for representing the complete network. So similar way, if I try any B class address, let's say 172.16.0.0, so I'm using 00 on the last 2 portions because it's a B class address and it has 2 host portions, so I'm making 2 host portions as 2 zeros with a default subnet mask. And if I click OK, again you can see the same message, the combination of IP and the subnet mask is invalid. But if I try to give something called 10.0, it's going to accept. It will not give that message because now this is not network ID. So here there are 2 host portions. So if these 2 host portions are zeros, then only we call it as a network ID. So if it is even 1 also, we don't call it as a network ID. Similar way, A class, if I try to give 10.0.0.0, so 3 host portions, so 3 zeros, it will not accept the same message you get here. Similar way, if I make it any one bit, let's say if I make this as 1, Now the device will accept because it's not a network ID. So in A class there are 3 host portions. So last 3 host portions, if they are zeros, then only we call them as network ID. So the first IP address of the range, in general we say, is reserved for representing the complete network, and we cannot use that address. That's what you can see. The first IP address of the range, it represents the complete network and cannot be assigned to any device in the network. So network address is represented with all zeros in the host portion. If you write zeros in the host portion, generally it is referred as network ID. One host portion, then 1 0, two host portions, 2 zeros, and 3 host portions, then 3 zeros. That is in case of A class. Similar way, so the first IP we cannot use. Similar way, we cannot use the last IP address of the range, and we call that last address as a broadcast address. So how we can identify broadcast address? It's a last IP of the range, and in general, whenever you see 255, you can see here this address. So we can see here you can see this is my last address of the range, and there is only one host portion, and that too it's actually binary ones. If you write binary 8 ones, this is wherever you see 1. So if you see host portion zeros, then we call it as network ID, and if you see host portion all ones, then we call it as a broadcast ID. So zeros means zeros and ones in terms of binary. So if you write this in binary, all ones represents decimal value equal into 255. That's what you'll see here. Similar way, it's actually the last address of the range. Similar way, if you see here, there are 2 host portions in B class, and both are 255, 255. So whenever you see host portion with all ones, probably it's the last address of the range, and whenever you see all 255s, in general we call as a broadcast ID. Similar way, if you take A class network, there are 3 host portions, so 3 ones means in binaries it is all ones, in decimal it is all 255s. We call that as broadcast address. Even this address also we cannot use into any device in network. The reason is, it is actually reserved for a specific purpose. It's the last IP of the range, and it generally represents with all bits in ones in the host portion. That's what we have seen just now. It is used to send broadcasts within the network and cannot be assigned to any device in the network. Which means, let's say in my network, so I'm using some B class. So I want to, what exactly I want is, I want to send the information to everyone. So let's say I have some information to send to everyone. So probably you don't need to go to each and every device. Suppose I want to send something to 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, like that. I want to send everyone. So if you want to send any information to all the devices in the network, you don't need to go to each and every device. Simply you can send to this address. So if you are trying to ping, let's say if you have a small LAN setup, probably you can try this. If you try to ping to 192.168.1.255, and you have some 10 computers in your LAN, you'll get the reply from all the 10 computers. So when you're trying to ping to this address, nothing but you are trying to send a broadcast message to each and every device in the network, and whichever the device is present or active, they are going to reply to that messages. So that is the purpose of this broadcast address. So broadcast address is used to send broadcast within the network. So if you have anything to send to everyone in the network, so simply send to this address. Similar way, any information to be sent for everyone in the network, send to this address. Similar way, A class. So how we can identify? We can identify by representing all ones or all zeros in the host portion. So in our network, even though we are saying C class network supports 256 addresses in one network, in that 2 addresses we cannot use the first and the last, and in general we call them as network ID and the broadcast ID. So those addresses are not valid and you cannot assign to any device in the network. So which means in total I can use only 254 hosts per network maximum in C class. Okay, so remaining all addresses generally we call them as valid addresses, which comes in between network and broadcast address, and these addresses can be assigned to any device in the network. So that's about network ID, broadcast address, and the valid IP addresses. Some basic examples. So let me take some examples here to just find out the network ID and the broadcast ID. Let's say I'm using some address 150.12.10.10. Now sometimes you'll be asked what is the network ID for this address. It's very simple. Identify the class. It's a B class. B class contains two network portions and two host portions. So if you write zeros in the host portion, it will become network ID. If you write 255 in the host portion, it will become broadcast ID. So which means 150.12.00 is a network ID and 150.12.255.255 is a broadcast ID. So similar way you can take same way as for B class and A class as well. So very important to identify the network ID, especially when we are getting into some routing technologies, where we get into some routing concepts. We need to advertise our networks. And to know your networks, you should know what is your network ID. Then only we can advertise, because when we do some routing configurations on routers, we need to advertise the network ID of our router. Okay. So now if I just list out the next thing is so we got some idea about the IP addressing, classes, classifications. Okay. Now the next thing we need to understand is about subnet mask. Like if you just try to see here, whenever we are trying to assign the IP address here, so I'm going to TCP IP version 4 properties, and whenever I type any C class address, let's say I'm going to type 192.168.10.10, and whenever I press tab button, automatically it will take 255.255.255.0. Similar way, if I try any B class address, let's say I'm just using some address, automatically it will take the subnet mask of 255.255. And if I try to give any address, any A class address, it will automatically take as 255.0.0.0. So now your Microsoft operating system is designed in such a manner that it will understand the class. So now here, so when I type in any A class address, it is automatically taking as 255.0.0.0, and whenever I type any B class address, it will automatically take as, and whenever I type any C class address, it will automatically take as 255.255.255.0, which means when I type 192.168.10.10, it's taking as 255.255.255.0, right, as per the C class. So now your Microsoft operating system is designed in such a manner that it will understand the class. It will see this first number and it says it's the C class, and by default C class will have 3 network portions and 1 host portion. So now this is your subnet mask. Subnet mask will tell how many network portions and how many host portions. So wherever there is 1, that is network, and wherever there is 0, that is host. So if you just try to see here, this is 255. 255 means nothing but binary values, all ones. Similar way it is 255. Similar way here it is 255 means binary ones. Similar way here zeros. So wherever there is 1, that is network. Wherever there is 1, that is network. Wherever there is 1, that is network. And wherever there is 0, that is host. So this subnet mask is actually saying how many network bits and how many host bits you have in that particular IP address. And by default, A class contains 1 network portion, so that's the reason we have only 1 255, and 3 host portions. That's the reason you have 3 zeros. So the same thing what we learned, network and host portions, but the devices understand how many network portions and how many host portions based on the subnet mask information provided just below to the IP address. And if you try to use your device without subnet mask, let's say I removed the subnet mask here, and if I click OK, you can see the message, the Microsoft TCP IP, you have entered an address that is missing the subnet mask. So please add the subnet mask, which means subnet mask is mandatory whenever you are trying to assign the IP address. If you don't do that, the device will not accept, because based on the subnet mask only the device will understand how many network portions and how many host portions. Okay, so that's the reason we have, these are the default subnet mask. So that's the importance of subnet mask. It's generally most of the time we just ignore that it takes the default, but this is the actual reason what exactly it will tell. It will tell how many network portions and how many host portions we have in that particular address. And these are the default subnet masks, but still we can customize it. So in case if you see something like this, sometimes in the production networks you will see subnet mask something other than default. You don't see this, you don't see this, you don't see this, but probably you'll see something new like this. So whenever you see this type of subnet mask, you have to understand it's a subnetwork, means the default networks are further divided into small networks. So this is our next topic. We will get into these subnetting concepts more in detail in our next coming classes. So just an idea what exactly that particular subnet mask represents. We'll get into more in detail in our subnetting calculations. So now we got an idea. Subnet mask differentiates network and host portion. Subnet mask will be is been given for identification of host IDs, and it represents all ones network, all zeros host portion. Okay. So now finally we need to, before we get into our subnetting calculations, probably the last thing we need to understand is what is private IP, public IP. So before we get into this private and public IPs, so first what we will do is we'll try to understand some other things, like, so let me figure out what are the addresses which are valid. In general, we discussed that we cannot use class D, we cannot use class E, because class D is reserved for multicasting, class E for R&D. So even if you try to assign these addresses, the device is not going to accept. And already we verified practically by doing this. Whenever I try to type any D class address, if you remember, we did this already. Whenever I try to type any D class address 224, the device says it's an invalid entry. Similar way, if I type any E class address also, will get the same message. So these are the two addresses which are reserved for this. The next thing, network ID and the broadcast ID. Even we verified this. If you try to assign a network ID, the device will not accept. This also we tried. If I just try to give some network ID, let's say B class network. So B class contains two host portions, so I'm making two zeros. You can see this is host portions and they are zeros. The device will not accept. Similar way, if I try to give broadcast address, that is the last IP of the range, and if I click OK, the device will not accept, because if you have all ones in the host portion, that is 255, we generally call it as a broadcast address. So we cannot assign network ID, we cannot use broadcast ID to any device in network. Apart from this, there are some other addresses, like anything starting with 0 in the first portion is not a valid address. So even if you want, you can verify. If I go to my place, network places, local area connection, TCP/IP v4 properties, if I try to give in the first portion, if I give 0, the device will not accept. So in the first portion, it should be at least 1 or any other number. So, but you can use 0 in the remaining portions, but not in all the portions, because all the portions zeros, again it becomes network ID. So in the first portion, you cannot use 0. Anything starting with 0 in the first portion is not a valid address. It's not a valid address. Similar way, there is one more address which is reserved, 127 dot address. 127 X represents anything in between 0 to 255. So generally there is something called 127 dot network. So let me try to go to my network places here, and I'm going to try to assign the address. If I try to type 127 in the first portion, you can see the message. It says IP address starting with 127 is not valid because they are reserved for loopback address. Please specify some other address in between 1 to 223. So now the reason behind this is 127 dot network, they initially reserved them as a loopback address. But now the question is, what is exactly this loopback address? So let's take one simple example to have some more easy understanding on this. So I'm going to take two computers here. Assume that they are connected in the LAN and the physical connection is perfect. the cable connecting between these two computers I connected across cable, so it's working fine. Or maybe through switch you can take, and I'm going to assign the IP address of first computer is 192.168.1.1, and for the next computer I'm going to assign 192.168.1.2. so probably they're on the same network, which means definitely they should communicate with each other, everything. So now if you want to test the connectivity, let's say I want to check the connectivity between them, so I can go to any one of this computer and I can simply say ping 192.168.1.2. I can simply type the destination IP address. So in general you'll get a reply message like I can show you a little bit. So probably here I don't have 1.2 computer, I don't think so. So if I just check my IP address, ipconfig, you can see my IP address of my device is the gateway address, that is my router address, and my IP address is 192.168.1.3 here. And if I try to ping 192.168.1.1, that is my gateway, I can see the reply message. So generally whenever you are sending a ping message, you'll get this reply. So this reply tells that generally the ping works based on echo request and echo reply messages. So when you generate a ping message, it is going to send the echo request message asking, hello, are you there? So now it is going to reply with the echo reply message saying that yes, I am there. So based on these echo messages, your particular reply comes, and these messages are controlled by ICMP protocol, Internet Control Message Protocol, inside the TCP/IP. So that's okay. So this is something which we generally do the basic testing in our LAN. But now let's say I'm not able to see the reply. Reply is not coming. Instead of a reply, but here I can see the reply is coming. If I just try to ping to some other device, so maybe I'm getting a message. Maybe the reply is coming from here. Maybe you'll see the message as destination was unreachable, or maybe you may also see something like some message. So I'm just trying to type to different address just to get some other messages. You can see it's not coming here. So probably you'll see the request timed out, or you'll see destination was unreachable. So whenever you see these type of messages, you have to understand that there is a problem. So in our example, the problem is I verified everything. I just confirmed that both the devices, the PCs are okay, no problem, and the cable connecting between them is also okay, and both the devices are powered on. The IP address and the subnet mask is also okay. Now you may have a small doubt. You may just want to verify that maybe your protocols connecting in the LAN, maybe there is some problem with the protocols. Maybe you may assume that your NIC card may be faulty, your LAN card, or maybe your protocols, TCP/IP protocols, are not working fine. So just to ensure that whether they are working or not, what I can do is I can go to command prompt and I can ping to any address 127 dot, let's say 111. Let me show you that. So I'm going to ping to 127 dot some address, anything you can type. Now you can see the reply is coming. The reply is not coming from any device in the network. It's actually coming from your local NIC card. So your local NIC card is replying and it's saying that I am perfect. So we call this as loopback testing. So this 127 dot network, they reserved for this type of testing purpose, to test your local NIC and your protocols. So this is the main reason for reserving. So they actually reserve the complete network for this. You can use 127 dot, any address you can type from 0 to 255, but don't use all zeros or all 255s in general. So you can use any address. So these are the addresses which are actually reserved addresses, we can say, or we can say the addresses which I cannot use them. So these things you need to keep in mind as well, which addresses we can use, which addresses we cannot use, and why we cannot use. Probably that is something you need to understand, especially when you are designing the networks. So you should have a very clear understanding of these things. So next thing the last thing we are going to see